We just finished talking about how to create a display for quantitative data, and now we want to talk about how to describe that distribution from the display that we have created. And what we will do is look at the shape, center, and spread of the distribution. So what we want to be able to do is to look at the data and help us draw conclusions or look at maybe some observations that we wouldn't have seen if we did not create the graphical display. And again, we're going to look at shape, center, and spread. For shape, there are three questions that I want to ask myself. Does the histogram have a single central hump or several separated humps? Is the histogram symmetric, and are there any unusual features? So let's look at each of those questions in a bit more detail. First, let's look at how many humps. Those humps are called modes, and modes are just the most frequently occurring value. So unimodal means there is essentially just one hump. And it's easier to kind of look at this in a curved pattern. Again, if I looked at this one, it looks like I have two humps. Here, it doesn't really look like I've got a hump. It looks like everything's sort of the same. So we would call this unimodal or one mode. This is bimodal or two modes. Multimodal would be three or more. And then uniform would be that there really isn't much of a hump at all. It's just that everything looks like it's about the same height. Then we look at the direction that it is skewed, or if it is symmetric. So if it's symmetric, I can roughly draw a line somewhere in the middle of the hump and be able to fold my graph in half and have it look roughly the same on each side. So it won't look exactly the same ever, unless it's a perfect normal model, which is very rare. Otherwise, we can look at a skew. And please remember that the direction of a skew is the direction of the tail. So here, I've got some numbers that appear that they could be outliers, and we'll talk about outliers in a little bit. But if I were to look at the overall shape of this graph, I can see that there is a tail here, and that tail tells me that it is skewed left. Again here, if I did the overall shape of the graph, then I definitely have the tail on the right side, so it is skewed right. So the shape, symmetric, skewed left, skewed right, etc. And the other things that we'll look for when we describe our distribution is outliers or gaps. So here, looking at my data, it appears that there is a gap here, and then there's an outlier. So there's one data set that doesn't, or data value that doesn't really fit with everything else. That's called an outlier. And we'll talk more specifically about how to determine if something is an outlier next week. Well, this week and next week, actually. Another thing that you might notice here, clearly this is bimodal. We've got two modes. We appear to have a gap in between there, and it looks like essentially that we have two clusters. So it would be really interesting to know exactly what it is that we're studying here, because this might be the difference of man something versus women something, because we all know metabolisms are different for different genders. It might be sugar cereals, etc. I can't really read any title or labels down here, which is why labels are so important. But it would be interesting to see what this is a distribution of. So we had some things to look at when talking about the shape. Now, in talking about the center, we're going to focus first on the median, and then in the next video we're going to look at the mean, which we'll talk about when to use which one. But for now, let's just look at the median. And the median is the center of our distribution, which means essentially we would line up our values lowest to highest or least to greatest, and we would count until we got to the middle. And the great thing about a median is half of our values are on each side of the median. That is what a median is. Just like a median runs down the middle of the road, it is the halfway point of our data. So to find the median, essentially first you put the values from least to greatest, and then we're going to count in. So here on my first data set, if I wanted to count in, I would cross off the 3 and the 19, the 4 and the 15, the 7 and 11, the 7 and 9, and I'm left with just one value in the center, which is 8. However, if I did the same thing for my second data set, 1 and 15, 4 and 12, I notice that I can't cross off 8 and 10 because there's nothing left. And so if I end up with 2 values instead, I'm just going to find the average of those 2 values, which means add them together, divide by the number of numbers, which is always going to be 2, and I would find that my median is 9. If I'm trying to find the center or median, dealing with a frequency table, you have to be very, very careful. You still must list all of the values and count your way in. In this case, I might just let StatCrunch do the work for me, and in a couple of videos from now I will show you how to let StatCrunch do this. But what I do want to stress to you is that I can't just count in the scores to the middle and say that 5 must be my median, because essentially my data set here is that I have a 1 and then a 2 and then 3 3s because the frequency is 3, and then 4 and then 4 5s, and so that's one way to do it, is to list them all out. But again, I wouldn't suggest doing it by hand. Let StatCrunch do the work for you. So we've talked about shape, we've talked about center, and now let's look at spread. Spread is just telling us the variation of our data. So is all of our data sort of tightly clustered around our median, or is it very, very spread out with with a lot of variation? And one way that we can describe the spread is to use the range of our data. And the range of our data, the important thing to remember here is that it's a value. So a lot of people look at my data set and say my range is 13 to 89. Well, my data certainly does range from 13 to 89, but my value of my range is found by subtracting greatest minus least. So my range of my data here would be 76. And that is the number that I would say. So the value of my range would be 76. Now, as you're describing your data, it's okay to say that the data range is 76, going from 13 to 89, but I would certainly include the range as an actual value when you're describing it. Another way that we might talk about range has to do with percentiles and quartiles, and we'll get more in depth in this when we talk about how to create a box plot. But essentially, a percentile divides the data into 100 groups. So whether we have, 8 pieces of data or 1,000 pieces of data, it essentially turns it into 100 groups and gives it a percentile. So the nth percentile is, so say like the 50th percentile says 50% of the data is below that. An 80th percentile means 80% of the data is below that. Quite often if you take a standardized test, they'll say, hey, you are in the 97th percentile, meaning 97% of people who took the test scored worse than you, so good job you. The median is the 50th percentile because the median is in the middle, so 50% of the data is to the left and 50 to the right. A couple of new things that we're going to talk about are called the quartiles. And the quartile, the lower quartile or first quartile, which I will always use Q1, the first quartile is the median of the lower half of the data. It's the same as the 25th percentile. So if you imagine our data listed from least to greatest, and we talked about how to count into the middle to find the median. If I then took just this half of data and I again found the median of that half of data, that would be the first quartile. If I did the same thing for the upper half of data, so for the numbers higher than the median, and found the median of that half, that would be my third quartile, which is equivalent to the 75th percentile. And again, that's called my Q3 or third quartile. So why is it that important? Because another measure of spread is to find the interquartile range, or IQR. The IQR measures the range of the middle half of data. So again, if I was looking at sort of recreate the picture where I had my median here, I had my Q1 here, I had my Q3 here. Essentially what it does is it finds the range of the middle half of data. The advantage here is if I had an outlier that was like way over here, that outlier is not going to be taken into account on my interquartile range, but it would be on my range. So again, let's take a look at the data here. If I counted in on each side, I would find that 38 is my median. Then what I would do is find the quartile, the first quartile, which is counting in from each side on the lower half of data. And I get 24 and 27. Again, I would add those together and divide by 2 to get 25.5 would be my Q1. I would do the same thing over here. I would end up with two values that I would then find the Q3 for, so 61 plus 75 and divide it by 2, and I would end up with 68. And so those would be my Q1, my median of 38, and my Q3 of 68. To find my IQR, I would take 68 minus 25.5, and my IQR would then be 42.5. So that's telling me the middle half of my data has a range of 42.5. What I'd like for you to do is take a look at this graph that I have and see if you can make some observations about the shape and the center and the spread. Once you've done so, press play to see how your answers match up with mine. So here are some observations that I came up with. The shape, as we can see, is unimodal, which means there's just one mode, and we can see that it is definitely skewed left because that is the direction of the tail. We haven't determined how to see if something is an outlier yet, but it looks like there's an outlier here and possibly one here, only because obviously we have some gaps in our data that we might want to pay attention to. The center of my data, I would really just be looking at the -0.2 because that's at the mode. I could do the math and determine the mean or the median, but we haven't really talked about the mean yet. The median, I could count in from each side and determine what value that appears to be, and that would be another way to find the center. The spread, we can talk about the range of 2 going from -2 to 0, but I also want to talk about just how varied the data is. So I said the majority of the data is centered around our mode. So here is the bulk of our data, and then we got these guys over here that may or may not be outliers. So this is just a way for you to kind of see how one might describe the shape, center, and spread of a distribution.